Number 1. Most of you is empty space. If an atom were the size of a stadium, its nucleus would be the size of a single pea in the very center. The rest, just empty space, with electrons whizzing by at near light speed. This is the structure of everything you see. This means that the atoms making up your body are mostly empty space. You are, quite literally, mostly nothing. And in that nothing, you are connected to the universe itself. A collection of stardust, mostly empty, yet miraculously you. Number 2. There's no universal now. Imagine you're at a concert, watching your favorite band. The guitarist strums a chord. That moment feels simultaneous for everyone there, right? Actually, it's not. The person in the front hears the chord a fraction of a second before the person in the back. Sound travels at a finite speed. Now, light is much faster, but it's still finite. It takes about 8 minutes for light from the sun to reach us. So, the sun you see now is how it looked 8 minutes ago. Now, imagine an alien in a faraway galaxy looking at Earth through a telescope. They might be watching the dinosaurs because the light from our present hasn't reached them yet. So, what's happening right now depends on where you are. Your now and the alien's now are completely different realities. There's no single, universal present moment. Number 3. Particles can be in 2 places at once. Until you look. Think of a particle like this spinning coin. Before you measure it, it exists in a superposition of all possible states, both here and there, simultaneously. But the second you try to measure it, to pin it down, this superposition collapses into a single, definite state. The act of observing changes the reality. This isn't just feeling. The double-slit experiment proves it. When we don't observe the particles, they act like waves, creating an interference pattern. They literally go through both slits at once. But when we add a detector to observe which slit they go through, they only go through one slit. The simple act of watching changes their behavior from a wave to a particle. So, in the quantum world, reality isn't fixed until it's observed. A mind-bending fact that underpins the universe. Number 4. Particles can be entangled across galaxies and affect each other instantly. Think of 2 coins that are mysteriously linked. If one lands on heads, you instantly know the other is on tails, no matter the distance. In quantum physics, this link is real. When you measure one entangled particle, you immediately determine the state of its partner, faster than the speed of light. This means the universe could be one vast, interconnected web of information, where everything is subtly touching everything else to cross infinite space. Reality, where distance is an illusion, and connection is fundamental. The universe is stranger than we can imagine. Number 5. Black holes evaporate. That's right. These cosmic vacuum cleaners, so dense not even light can escape, are slowly vanishing. The culprit: Hawking radiation. At the edge of a black hole, quantum chaos reigns. Particle-antiparticle pairs pop into existence. Sometimes, one particle gets captured by the black hole. The other escapes, stealing a tiny bit of the black hole's mass. Over unfathomable timescales, this process causes the black hole to shrink, eventually leading to its death. In its final moments, it erupts in a powerful explosion, releasing all its stored energy in a burst of Hawking radiation. Silent end to one of the universe's most mysterious objects. Number 6. The universe has no center. You might think of the Big Bang as an explosion from a single point, but that's not the whole picture. Imagine the universe as the surface of a balloon. Every galaxy is a dot, and as the balloon inflates, every dot moves away from every other dot. There is no single starting point. From our vantage point on Earth, it seems like we are the center because everything is moving away from us. But an observer in any other galaxy would see the exact same thing. This leads to the next big question. If the universe is all there is, what is it expanding into? The answer is nothing. The universe isn't expanding into a pre-existing space. Space itself is being created everywhere, between every point. So, in a way, we are all at the center of our own universe, a humbling yet profound fact of our existence. Number 7. Absolute zero can't be reached. Not tomorrow. About 1,000,000 years from now. It's a rule written into the fabric of reality. Absolute zero is the theoretical temperature where all particle motion stops. But here's the catch. You can never remove the last sliver of heat. To cool something down, you have to dump that heat somewhere else, which always leaves a little behind. It's like trying to empty a bottle with a hole in it. Even the coldest known spot in the universe, the Boomerang Nebula, is still a frigid but not absolute 1 degree above zero. A reminder that in the vastness of space, some limits are truly absolute. A cosmic law we can never break. Number 8. Forces aren't really forces. What we perceive as a force, like gravity pulling this apple, is actually a consequence of something far stranger. Imagine 2 people on ice. By throwing a ball back and forth, they push each other apart. They feel a force, but it's just particles being exchanged. In reality, the electromagnetic force between charged particles is carried by virtual photons, popping in and out of existence. The strong nuclear force, which holds atoms together, is mediated by gluons, creating a powerful, colorful field. And even gravity, a force that shapes the universe, is thought to be carried by theoretical particles called gravitons, a cosmic exchange of influence. So forces aren't magic. They're a dance, a constant and visible exchange of particles that holds reality itself together. Number 9. Magnets can levitate frogs. It sounds like magic, but it's pure physics. In 1997, scientists made a frog float in midair using a massive magnet. The secret is diamagnetism. All materials have this property, which means they create a weak magnetic field that opposes any external one. Since frogs are mostly water and water is diamagnetic, the opposing force from the giant magnet is just enough to cancel out gravity. In fact, everything is diamagnetic to some extent, even you. The only reason you don't float is because the force is incredibly weak. The next time you see a magnet, remember, it's not just sticking to your fridge, it's a window into a world where frogs can fly. Number 10. Water expands when it freezes. Unlike almost every other substance, it becomes less dense, which is why ice floats on water. In its liquid form, water molecules are packed tightly, but when frozen, they form a unique crystal structure that takes up more space. This simple quirk of physics has a dramatic impact on life on our planet. Floating ice acts as a vital insulator, preventing entire bodies of water from freezing solid and allowing marine life to survive the harsh winter. Simple phase change, a world of difference. The reed-and life survives the cold. Number 11. The laws of physics may change over time. In our everyday world, physics is reliable. A pendulum swings, an apple falls, all governed by unchanging rules. But what about at the birth of the universe? In the searing heat and density of the Big Bang, those same rules might have been very different. And around black holes, the heart of darkness itself, the laws of gravity, as we understand them, simply break down. So, are the laws of physics truly universal? Or are they just a local set of rules in our corner of the cosmos? The universe is full of surprises. Number 12. The universe might be a hologram. What if everything you see, touch, and feel isn't real? At least, not in the way you think. The holographic principle suggests that all the information in our 3D universe is encoded on a 2D surface, like a cosmic DVD. This means our reality could be a projection, a 3D illusion created from information stored on the edge of space itself. Your entire life, your thoughts, your emotions, all a meticulously detailed projection of data. While we'll be living in a hologram, the jury is still out. But isn't it amazing to think about? Number 13. Randomness is fundamental. You think a coin flip is random? That's just ignorance. If you knew every variable, you could predict the outcome with certainty. But in the quantum world, randomness is not a lack of knowledge. It is the fundamental nature of reality itself. There is no hidden information that can tell you exactly when a radioactive atom will decay. It is purely random. This means the universe isn't just complex. At its core, it's built on a foundation of pure, fundamental randomness. Number 14. The vacuum has energy. What we think of as empty space is actually a boiling sea of virtual particles hopping in and out of existence. This is the quantum vacuum energy. In fact, the energy contained in a single cubic centimeter of empty space might be greater than all the matter in the observable universe. And this energy of the vacuum could be the answer to one of the biggest mysteries in physics. What is causing the universe to expand faster and faster? Of the energy of nothingness itself pushing the cosmos apart? The answer might be blowing in the cosmic wind. Number 15. Physics doesn't know what 95% of the universe is made of. Everything we see, touch, and understand, all the stars, planets, and galaxies, makes up just 5%. About 27% is dark matter. It's invisible, doesn't interact with light, but its gravity is holding the universe together. And the remaining 68% is the dark energy, a mysterious force that's not just expanding the universe, but speeding up the expansion. The universe is a mystery wrapped in darkness, and we've only just begun to ask the right questions.